session, again we are going to discuss about specialized injection molding process. So the specialized injection molding process is majorly used to make the complex product. Uh, but even though if you are making the big product, the material the consuming that material for making those product, it's very less amount of material is required. So that is the one of the advantage of this specialized injection molding technique. And moreover, the product which are prepared from specialized injection molding technique, those product have good enough strength for end use applications. So if you are reduce the material for making that product, but still we can uh, ability to enhance the property of that product that is used for end use application. This is the one of the advantage of this specialized injection molding technique. So in this technique, the last class we were discussed about gas assisted injection molding process. So in this gas assisted injection molding process, the construction of injection molding machine, it slightly differ. And additionally, one more accessory we can use here, that is called that is called gas cylinder. So this gas cylinder which is fitted in the mold section. So until the injection unit, all the component, what are the component are present in injection molding machine, those components are present in specialized injection molding construction also. But in this gas assisted injection molding technique, in the mold section, the specialized vent, that is the vent which is used for gas flow. So during that filling time, first the material is injected into the mold section, and followed by gas is also injected into the mold section. So because of this gas flow, the gas which is stretch the molten polymer. So this because due to this reason, the molten polymer, it's stretched out, and it's form a solid structure. So with the help of the gas, you just push the material, push the molten polymer against the wall of the cavity. So based on this principle, you can make the product from gas assisted injection molding technique. So the way of gas inserted into the mold section, based on that, there are two more techniques are available. The first one is external gas injection unit, internal gas injection unit. So in this technique, in this internal gas injection molding technique, here the in between the monolayer of the molten polymer, in between the gas is inserted between the molten polymer. But in the case of external molding technique, in this technique, the one layer of molten polymer, it's one layer of molten polymer, and after that the gas is flow over the product. So the way of gas flow in internal gas assisted injection molding technique and external gas assisted injection molding technique, it is differs with each other. And the same way, the other specialized injection molding technique, this is also um, used to make various product. This is called as this is known as the water assisted injection molding technique. So this in this water assisted injection molding technique, uh, here instead of gas, the water is used. So in this water assisted injection molding technique, it is a recent technology which is used to form the hollow like product. So majorly the water assisted injection molding technique, it is the newest way to mold hollow or partly hollow parts. So it is basically similar to the gas assist molding technique. Here the core route of thick section. But in the case of water injection molding technology, it comes a big advantage over the gas assisted injection molding technique because the thermal conductivity of water is 40 times greater than when compared with gas. So the water heat capacity is 4 times greater than the gas. So with the cooling capability of water assisted injection molding technique, the cooling cycle time, so the cooling cycle time can be reduced to only 25% of that of gas. So these all are the advantages of water assisted injection molding technique over the gas assisted injection molding technique. And the pressure. So the low pressure injection molding technique, it is that very faster cycle because the water it will give cooling very fast when compared with gas cooling or in gas assisted injection molding technique. So this uh, water assisted injection molding technique, it will give more uniform part wall. At the same time, material savings it is also uh, happen because when the water is flow in between the molten polymer to produce the hollow parts from this water assisted injection molding technique. So in this water assisted injection molding technique, there are four different approaches will be there. So why the water is very much import have a big advantages when compared with gas assisted injection molding technique. In general, when compared with water and gas, the gas is compressible one, but water is not. So when the water injected into the melt, it's leading edge of the water to form the solid boundary or highly viscous membrane. So this membrane, it forces the molten material forward instead of the polymer forcing the water to the side. So the primary reason for this action is higher viscosity and incompressibility of water when compared with gas. So this viscous front, it acts as the ram that cores out the part. So the front is also cools the melt as it is pushed down the mold cavity by water pressure. So this gas assist operate at a pressure of 300 to 2500 psi, while the water assist generally operate in the range up to 4350 psi. So the gas, it is can migrate into the molten polymer or polymer solution, but water is a different story. If gas it permeate the polymer, it can roughen the inner surface of the part. When the gas it migrates out again. But in the case of water, some of the polymer are able to absorb the moisture content. For those polymers could not ability to process in the water assisted injection molding process. So in this water assisted injection molding process, it's somewhat benefit when compared with gas because of these characteristics, because water is incompressible one and higher viscosity when compared with gas. So this higher viscosity water which act as the ram while the molten polymer entering into the mold section. So because of this reason, the ram it's core out of the part. Then the front also cools the melt as it is pushed down the mold cavity by water pressure. So the water pressure it's somewhat high when compared with gas pressure. Normally, in the case of gas assisted injection molding, the pressure range is 300 to 2500 psi. But in the water assisted injection molding technique, they are using 4350 psi. So because of high pressure, the orientation of the molecule, it is also very high. So due to this reason, the product that are produced from water assisted injection molding technique, it is somewhat high mechanical property when compared with the product which is produced from gas assisted injection molding technique. So in this other differences between the gas and water injection, uh, this gas can branch into smaller flow stream inside the part, so that creating an undesirable fingering effect and unpredictability of gas behavior. It makes it very difficult to control of wall thickness of the part. But while when instead of gas, the water which is used in that to making the polymer product, uh, with the help of water you can easily control the flow of water. So due to this reason, we can somewhat manage the wall thickness of the part. So this is the one more difference between the gas assisted injection molding technique and water assisted injection molding technique. The parts that are produced from the gas assisted injection molding technique have smaller flow stream inside the part. So this because of unpredictability gas flow or gas behavior, it makes it very difficult to control the wall thickness of the part. But water, it make the wall thickness uniform and repeatability. And moving to the shrinkage and sink reduction, the mold can be pre-pressurized with gas before melt is injected, or gas can be introduced between the non-apparent side of the part and the mold. So here the surface of the part, it could not be used for that purpose. So the competition between these two specialized technique, uh, when compared these two, the water assist injection molding technique, it's somewhat better technique when compared with gas assisted injection molding technique. So what are the approaches? There are four different approaches in the water assisted injection molding technique. The first approach name is short approach. Second approach name is pushback approach. Third one is overflow approach. Fourth one is flow process. So each approach have different the different way of process. It can be done in the water assisted injection molding technique. So it's applied one or four processes. So the process is, each process have slightly varied with each other. So when compared with gas assisted injection molding technique, here the polymer is filled in the mold section, and then the water is introduced into the mold section. So and evacuation of the water by gravity of air. So in that short approach, this process, it is also called as the bubble process or blow up process. So this process, during this process, the polymer material, the molten polymer material, it's partially filled in the mold cavity section. Then the water is injected into the mold before the end of melt injection. So this, because of their higher viscosity and when compared with gas, and secondly the water which is pushing the material to the end of the cavity for final packing, then valves are closed off, melt from the injection unit and water from the pin So a release valve for the water opens, allowing the water to drain from the part. So a valve is mounted at near and end of fill, can facilitate the water evacuation using the compressed air. So this method, it is a very good method. It's very good for to produce the very thick part. It involved there is no wastage material and there is no regrind. It's not required for this process. So the entry and the exit point of water, it can be at or near the same point. So the entry and the exit point of water can be the same location. So the what where the water is flow or entering into that molded section, the same way the water is out from this mold section. What are the disadvantage of this approaches? The tight control is required, and secondly, the too little material can lead to water bursting through the melt into the mold. So due to that water injection pressure, it's very high when compared with melt pressure to push it to end of fill. So in this point, at this point, from resin injection to the water injection, so may cause a hesitation mark on the surface of the part. So a finish may not be feasible. So first, also the material at the end of the shot is likely to form the thicker section that could lengthen the cycle time. So this is the shot process. So in this shot process, in this shot process, first the mold cavity is partially filled with polymeric material. After that, the water is entering into the mold. So in this case, the water entry point and exit point both are maintained at the similar same location. So the water, it is flow inside the molten polymer to push the molten polymer till the end of the cavity. So due to this reason, the polymer is well formed and completely filled in the cavity with the help of water. And after filling the cavity, the water is leave out from the molding section. Leave out from the molding section. So this is the first approach. It is called as the shot approach. So when you are moving to the and moving to that second approach or second approach of WAIM, it is that flow process, sorry, pushback process. So in this case, the melt is completely filled the cavity. So after that, the opening the water pin, which is located near the end of melt fill, which pushes the excess the melt back into the headspace in the injection unit. So the advantage of this approach include the absence of scrap material because here the melt is pushed back with the help of this water. So the water pin, it's located where the melt is reached at that cavity section. So at the end of the mold or at the end of the molten polymer region, the water pin will be there. So through the pin, the melt, sorry, the it will pushes the excess of melt back into the injection unit or head space in the injection unit. So it is from this approach we can save the material, because we cannot get any flash mark or extra material. It's not leaking out from the mold section. So in a due to this reason, the scrap is absence, and also ability to achieve the good clarity product. So it require for this pushback technique, it's require the special design nozzle and check ring, where to accommodate the material, it's coming back into the injection unit. So the users, it must be very careful not to let water penetrate into the injection headspace, because it leads to severe problem for further processing. Maybe this problem could be a big problem with hygroscopic material like nylon material. Every part of the process is much under control, and controlled pressure and control temperature in order to get the consistent flow of material. So the known amount of material back into the molding unit, the returning material may be of the temperature or pressure is different than still in the barrel section, it creating the process variables that may influence the next shot. So the separate air system or water delivery systems are required to balancing the material in the water assisted injection molding process. And third approach name is overflow. So here the mold cavity is completely filled with melt and close off by the wall. Then a separate pin is open in the mold section for water injection. So the simultaneously the valve at the end of the cavity opens a path from the main cavity into a second and overflow cavity. So the incoming water, it displaces the melt which is pushed into the secondary cavity. The secondary valve is closed for hold and pack. So water can be expelled through the cavity or evaporation. So this approach is reportedly can provide the class A surface. It means that good clarity surface we can produce from overflow processing method. So in that overflow processing method, the mold cavity is completely filled with melt, and which is closed off by the closed nozzle or return valve. To separate pin for producing that separate pin that opens in the mold for water injection. So a valve at the end of the cavity which fills the opens a path from main cavity into the second and overflow cavity. So the incoming water is displaces the melt for hold and pack. It can be expelled through gravity and evaporation. This approach, this type of approach will provide the glass surface, and it is also very much closest to conventional injection molding process, and it will offer the wider processing window. This lab furtherly requires low water pressure than the shot method. On the downside, the displaced material from the core has to be recycled. And the final approach for water assisted injection molding technique is flow process. So the flow process, it is nothing but the combination of shot and overflow process, which is flushes the water through the part of the enhanced cooling. The mold cavity is filled, a specialized valve is open at the end of well, so the water is break through the melt and streams through the valve into the water recirculation circuit. So the advantage of material is savings and high rate of cooling. Disadvantages include is blemish occur at the tip of the part. Also, the low pressure could cause water to seep between inner mold surface and outer part surface. So, what are the common factor we need to consider in the water assisted injection molding techniques? We need to purge the water because sometimes the gravity is work in some situations, but the gas assisted injection molding technique systems, including the pressurized gas barge and for injection for sensitive material, alliance and capillary gas assist system, the secondary water system, and followed by the gas purge. So these all are the different approach. First approach name is short approach. In the short approach, the polymeric material are partially filled in that mold section, and secondly, the water is injected. This in this first approach, the locating pin, that is the water injecting pin, is located nearby the water nearby that entry of the mold section, entry of that mold section. So through this way, once the material is secondly, the water is came with this action. So can you able to see my screen? Can you able to see my screen?
Yes, ma'am.
So this is the four method. The first method is short method. In this case, anyone please reply me. Can you able to see my screen?
Yes, ma'am.
Okay. So in that first approach method, the short method, first the melt is partially filled in that cavity. Then the water is injected into that cavity. This water, which is act as the ram, it push the molten material until the bottom of the cavity. Until the bottom of the cavity. So because of high viscosity of fluid and high viscosity of fluid, and we can easily control the water flow. Because of this reason, you can make the thick parts from this approach. And the second approach is pushback method. So in this pushback method, first the material is injected into the cavity fully. The material, the molten polymer completely fill the cavity. Then the water is insert through from end of the molten polymer. From end of the molten polymer, the end of the molten polymer, the water pin where the water is entering into the mold system. This location, it's slightly differ from previous approach. In this approach, the water pin, it's located after the polymer melt. After the polymer melt, it's not so from this point the water is injected. So through this way the water is injected. So because of this reason, this molten polymer, it's pushed back to the injection unit. Pushed back to the injection unit. So in that injection unit, the specialized design accumulator is there, where the material is gathered or accumulated at the particular portion in the injection unit. So for this, we can use specialized design of non-return valve is used. So here the molten polymer, it is pushed and sent back to the injection unit. So this is the pushback method. And third one is overflow method. In the overflow method, the molten material, it is formed partially filled in the cavity, then fluid which is act as the narrower, and fuel bed, it is have some. So in this technique, first the valve is closed, then the melt is filled partially in the cavity, then the valve is open. So during this time, the fluid, it is flow through the molten polymer. So fluid, it is entering into the molten polymer. So here the flow is somewhat high. After this wall, the flow is somewhat high. So this flow, it is considered as the overflow cavity. And the last one, fluid flow out. So this fluid flow out, it is somewhat major role placed by the water assisted injection molding process. So in this case, the fluid is completely filled in that cavity, and secondly, the water is injected into the fluid to make the part from this four different approaches. So each approaches which is used to make different type of product and different thickness of product. These all are the four approaches the people are used in water assisted injection molding technique. And move on to the, what are the materials are suitable for water assisted injection molding technique. So, and move to that next process. It is called structural, sorry. So this is the water assisted injection molding technique. And so what are the materials are suitable for water assisted injection molding technique? The two leading candidate for early commercial uses are one is nylon 66 and another one is polypropylene material. Also being tested to polycarbonate ABS and PCABS blends, high impact polystyrene, polybutylene terephthalate, acetal, copolyester TPE. These all are the different examples. Sorry, these all are the materials that are used in the water assisted injection molding technique. So this from this result, the Zytel EFE, this is one of the nylon material. The nylon material trade name is Zytel. So this Zytel material, it consists of 90 to 100, 90 to 30 percentage of glass filled nylon 66 in making in one diameter. So and DuPont, it is also provide many materials to process in the water assisted injection molding technique. So what are the requirement of material that are used in that water assisted injection molding technique? I already told there will be a many parts, most of the hollow thick parts or thick section within parts can enable to produce in that water assisted injection molding technique. So in this uh, in this water assisted injection molding technique, the materials, so the materials, it should not be absorb the moisture, it should not absorb the moisture, otherwise it leads to a severe problem over the end product. So in that in this water assisted injection molding technique, first in that four approaches, uh, each approach it's have a slightly different with each other. So in that overflow process, the mold cavity is completely filled with melt material and closed by a wall. Then a separate pin is then open in the mold for water injection. Simultaneously, the wall at the end of the cavity is filled. uh, Wall at the end of the cavity fill opens the path from the main cavity into the secondary and or overflow cavity. So the incoming water displaces the melt which is pushed into the secondary cavity. Then the secondary valve is closed for hold and pack. Then water can be expelled through gravity or evaporation. This approach reportedly can provide the class A surface. It is closest to conventional molding process. It's offering a wider processing window, and it also require lower water pressure when compared with the short method. So the displacement of this material has to be displaced material from the core has to be recycled, and a secondary trimming is needed to separate the finished part from the excess material in the secondary cavity. So this is the process. This process, it is named as the overflow process. So what are the product are produced from water assisted injection molding technique? Generally this water assisted injection molding technique is used to produce the um, hollow like product. So products that are produced from water assisted injection molding techniques assisted like door handles and car door handles, refrigerator door handles. So this type of product are majorly prepared from water assisted injection molding technique. So when compared with gas assisted injection molding technique, the water assisted injection molding technique, it is somewhat we can manage the wall thickness of the part, somewhat we can control with the help of this water. So in this water assisted injection molding technique, it will give good quality product when compared with gas assisted injection molding technique. And move to the next specialized injection molding technique. It is called as the multicolor. So multicolor injection molding. So if you see some of the parts, one part it have a two color. So can you tell me what is the part is that? Anyone can see that kind of part in your home? Only one product. That one product itself with two colors. Anyone? Anyone? Can you tell me the product with the two colors in your day-to-day life? In our day-to-day life, majority of the people are use this product. Anyone? Can you tell me? Toothbrush handle. So this toothbrush handles, it's majorly it's produced from two color injection molding machine or multicolor injection molding machine. So in this double color injection molding machine, it is majorly used two color or double color mold product. Like similarly, one second. So like this like product that are double injection molding technique and this type of products, and in our day-to-day life we are using that. So this type of multicolor, if a bucket and brush handle and uh, like a button, like a double injection molding technique, especially the keyboard buttons and mobile buttons. The on off switch it is different color. Rest of the switches are in different color. So those type of product are made by the multi-color injection molding technique, or some of the product only have two colors. So this, if you take this product, it is only two color. So this type of product are made by the multi-color injection molding technique. This is that multi-material injection molding. In this case, the blue color it's one of the material, and white color it's another material. Likewise, so this type of product, it's it's made up of multi-color or two color injection molding process. So now how to uh, make that multicolor injection molding. This multicolor injection molding or two color injection molding. If you have two color injection molding, it consists of two injection unit for injecting the two different molten resin. If the multicolor injection molding technique, then the three different injection unit are used. So here the molten resin is mixing at the manifold section, manifold around, with at least three injection units are disposed. So each unit is disperse the material into the mold section in different time. So based on that, at one part, we can get the different color. So the multicolor product, we can make it from two color injection molding technique or multicolor injection molding technique. Simply abbreviated, it is termed as the triple M, multicolor injection molding process. So in this process or this machine, which consists of three injection unit, each injection unit should process the different material. Each injection unit process the different material. Then at the mold section, before the uh, dissection, before the die unit, at manifold section itself, uh, the polymeric material, the three different flow combined together, mixed together to make the product. So that's why we can get the multicolor product from the injection molding process. So in this multicolor injection molding process, it's normally used two different material, and moreover, each material have some unique characteristics with each other. So the principle of this mission, it's very simple. It's multicolor molding in which various kinds and colors of resins are injected from the injection unit and enter into the mold section. Here the various kinds of color. So injection unit and enter into the molten resin mixing manifold. In the manifold, a compounded or layered flow of various kinds or colors of resin is then charged into the mold cavity to form the multicolor product. So the various multicolor pattern can be produced by not only controlling according to this time chart or another, but also we can controlling the temperature of the heating cylinder. So the pressure, speed of injection, and so and so. So this various pattern can be obtained by using different structures of detachable attaching chamber, which is obtained by the injection control. And the process. So there are two color process or three color injection molding processes have been practiced. In this machine, the mold is turned from side to side in order to receive the two or three injection streams, one after another from the injection nozzle. So the product frame is built from the beginning, is filled with each color, and secondly, it's turned. So in this injection unit here, the up to the injection unit, each and every component or similarly what are the parts are present in the standard injection molding machine. After but the injection unit, the number of injection unit, it's high. So in that conventional injection molding machine have only one injection unit, but in the two color and three color injection molding process, it have two or three injection unit. Each injection unit produce the different material. in different color. So the mold is turned from side to side in order to receive the 2 or 3 injection streams, one after another, from the injection nozzle. So the product frame is built from the beginning, is filled with each color resin at the selected area. So there is another known process in which two color resins individually molten in 2 injection unit are independently and simultaneously injected through one nozzle to form the color pattern. So there are different way the color formation over the product, different color formation over the product. The first principle is, um, in this first stage, the 3 injection streams, after the 3 injection streams are there, so the mold is move or turned from side to side in order to receive the stream from each channel, each injection unit. So for that, the mold is move from up and down or side to side. So or tilt at 360 degree, tilt at 360 degree to receive the stream from first injection unit, then again tilt 360 degree unit, receive the another molten polymer from second injection unit. That is the first process. In the second process, in that second way of color processing is, at one product, layer by layer the color is making. So in this process, the only one nozzle unit will be there. So the two colored resin individually molten or separately molten in each injection unit. Then it's independently injected the material through the nozzle to form the color pattern. There is the another approach is sandwich structure. So the upper layer and lower layer, or on other hand, we can see the skin layer, it is in different color. The middle layer, it is in different color. So it is that successfully injected through common sprue out of separate injection unit. So these are all the different process we can make the multicolor product from this multicolor injection molding process. The first approach is mold is moving, and the second approach is, here there is no mold movement, only the material, it is flow from the separating injection unit through the nozzle to form the different color pattern, that is sequence color pattern. In the third approach, to make the sandwich structure product, so in this product, the upper and the lower layer, which is comes out from same injection unit, the in between the middle layer, it's from the second injection unit. So likewise, you can make the injection. You can make the multicolor molded product. So this multicolor molded product with intricate designs for a high decorative effect. So majority of the, if normally the people are looking the aesthetic looking of plastic product, so that different colors, one product have different color. Likewise, the tea mugs, the inside color is different, the outer layer is different. So this high decorative effect are in demand. So in the conventional injection molding machine, however, this conventional injection molding machine, we can ability to process the only one material at one time. So we cannot make any three-dimensional appearance of complex or multicolor patterns with more than 3 colors. We cannot ability to produce from the conventional injection molding machine. So if it is therefore an objective of this invention is to overcome this deficiency in the conventional injection molding machine. So the another object is to provide the decorative molded product with intricate designs. And the third approach is the multicolor molding process and machine capable of injection molding of a multicolored pattern of more than three colors without turning the mold from side to side. This is the third objective of this new invention. So in that multicolor pattern, at least three colors are arranged in an overlapped fashion, presenting a three-dimensional appearance with continuous uh, gradations of color with reproducibility. So this multicolor injection molding process, it's one of the new invention of that injection molding technique. So the novel features of the present invention will become more fully apparent from the following description of following description. So the four color molding machine is schematically a machine stand is provided, a top which is literally fitted a rom cylinder and from which emerges the end of the piston rod and which is coupled to the piston of the cylinder at one end and the fixed to the movable plate at the other end the movable plate. So So the molding process using the four color molding machine, that is the invention, the new invention of this era. So this four color molding machine, it's constructed, it's carried out the follow. First one is molten resin mixing manifold is six housing. So within this arranging chamber, it's attached to the stationary mold. Um, eight having the cavity mold is it and having the cavity is 9 and injection unit is 10 through the 10D are heated by the heater to the suitable temperature. Then for optimum injection molding process, the particular resins to be injected. So the temperature control in the manifold section because all the three channels combine together at the manifold section. So we need to control the temperature. Otherwise, all the materials are flow at same time. All the materials can ability to flow at same time. So with the help of temperature you can restrict the flow of material, especially at the manifold section. So the temperature controller for the manifold and these injection units largely influence the resin flow and significant influence on the reproduction and design pattern. So when the product is, for instance, a round gap, a top surface presents an annular pattern, the side surface of stripped pattern. So the multicolor injection molding machine, it is also have following unit, injection unit, clamping unit, hydraulic unit, electrical unit. So this injection unit, it consists of double cylinder injection system. It means that two injection unit and a high quality barrel and a screw, nozzle, steel hopper and multi stages of speed, pressure and position for injection, multi stages of speed, pressure and time for hold on, and multi stages of speed, pressure, time for charge. So these all are the most important point to be considered in the multicolor injection mold parts. So, what are the benefits of multicolor, multi-shot, or two-shot injection molding process? In this process, we can use different resin are injected into the mold in separate nozzle. Then the resins or materials are chosen must be similar in melting point. The material selection for the multicolor injection molding processes, it should be similar in melting point. Otherwise, one one material it's a flow very faster when compared with other. To avoid this, we should select the material for each injection unit. Both material or have somewhat similar melting point material, so that only the injection molding machine can use the heat range to melt both material concurrently manner. Then the multi product concept using multi shot and a two shot injection molding machine, which is used to produce the soft handle insert, multi color parts, product with molded seal, and parts requiring flexible hinges, assemblies with the movable component. The advantages of this process is more complex parts which create the unique final assembly. New product, a creative advantage over the competition with the new color, texture, and materials they have not through off yet. And overall the part cost it's reducing secondary assembly processes and associated labor cost, and production time it is also can be reduced. The tooling it's won't be required for this multi colored injection molding process, and improve the product quality and high dimensional tolerance and accuracy. So in this multi-color injection molding process which is used to make the aesthetic look product. So let us see how the product is working. Our product is manufacturing from the multicolor injection molding machine. In this multicolor injection molding machine, um, can you see my screen? Hello? Hello, can you able to see my screen?
Yes, ma'am.
Okay. So this is the principle that is followed in two color injection molding process. So here there are two injection unit are used. So each injection unit which is used to provide the flow, that is material flow into the mold section. So first the material it's filled in that cavity from the first injection unit. So that green arrow, it shows that the robot transferring part from upper cavity to the lower cavity as an insert for over molding. So this is a kind of insert. So in that second shot, in that first shot, in both cavity which is filled with blue color, then after rotating this mold section in order to receive that material, then again over the blue color, the orange color flow will be there. So this green arrow which shows the pattern and the mold is clamped closed for over molding process to begin with the insert. One second.
Ma'am, you are not audible, ma'am.
Sorry. So this is the first step that are involved in that multicolor injection molding process. So in the two color process, the two injection units are used. Each injection unit process the two different material. But the important point here is both materials should have similar thermal history. While you are process these two material, both material it should have same thermal history. It means that both material it's somewhat melting point similar manner. Otherwise you cannot control the flow of the material from each unit. So this first the mold is closed. The material is filled in that cavity, first cavity. After that, the mold is open. Then the cavity is moving in order to receive the second material. At the same time, the first position, the empty cavity will be there. So in order to receive the first material. So both in the third step, again the press is closed. First shot injected into the first mold, second shot injected into the second mold. Then again the mold is rotated. Then the second shot it's moving to here in order to receive the second material. So after finally you can get this kind of product from this uh, two shot injection molding process. And furtherly you can So this type of mold is rotated. Then after that, the part is ejected from here. Now the part is ejected. The second material is how is that? So this type of product is just made up of So this type of product it's also produced from double color injection molding process. So here the two injection unit, that is separate hopper. One hopper it consists of white color pellet, another hopper it consists of red color pellet. So these all are the parameter we should enter in that process. That is position. So I hope you all are understand well about multicolor injection molding process. So next class we are going to see about structural foam injection molding process. Until do you have any doubt, please ask me regarding water assisted injection molding and multicolor injection molding process. Otherwise, you may leave on this meeting except Karthik and one more candidate. Yeah, Karthik alone. Thank you all. Thank you for your cooperation. Stay back, Karthik.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Yeah, Karthik and Sabik Nafel. Please stay on this line. Okay, Sabik Nafel, are you there? Sabik? Sabik, are you there? Karthik? என்னோட கேலண்டரே பார்த்துட்டு இருக்கேன். மீட்டிங் முடிஞ்சு 1/2 மணி நேரம் ஆகுது, இன்னும் லைன்ல இருக்காங்க. இன்னும் லீவ் ஆகல, லைன்ல தான்.